Hi all the students of Narayana 9th standard. Today here I am in front of you all to discuss the topic work power energy assignment number 22. Let us go with the first question which is given to you all in assignment. Now the question which is given to you all is the velocity of a body revolving in a vertical circle of radius r at lowest point root 7 gr, the ratio of maximum to minimum tension in the string they are asking you. Now let us try to analyze this question. When you are taking bob which is hanging over here, let us think the velocity which they have given is root 7 gr at the lowest point and now as per the question the lowest point is over here. Now when you are taking that lowest point they have given root 7 gr. Okay, now at that particular point your tension is going to be maximum at the lowest point. So let us find T max. T max is nothing but mv square by r plus mg. Now if you try to substitute the values, you are going to get v square have to be substituted. So v square is m into root 7 gr. So this root and that square gets cancelled anyway. So I am going to write it like 7 gr by r. So here anyway r and r is going to get cancelled. So now your total value which you are going to have over here is 7 mg plus mg. You are going to get it like 8 mg. That means your T max value is 8 mg. Your T max value is 8 mg because if you substitute this value over here and try to solve it, you are going to get 8 mg. Now one more thing which I want to discuss is they are asking you the minimum tension. So when you are trying to find out the minimum tension, T min, actually minimum energy, minimum velocity which is required to complete a complete loop, that means to complete one circular rotation, is going to be root 5 gr. Root 5 gr. Okay, root 5 gr. But how much they gave you? They gave you 7 gr. Now okay, when I am having root 5 gr, if you observe that, if you consider this into 4 halves like this, if you consider this in 4 halves, 1 2, now let us think this is 1 2 3 4 and 5. Again, to complete one complete rotation you have to come and reach this particular point you have 5. So I am telling you 5 root 5 gr. This is a shortcut point of view. I am explaining you like root 5 gr you are going to get. Now what happens is, again if it have to reach to the highest point, then only its tension is going to be minimum over here. Its tension is going to be minimum in the string when it is at point 3. When it is point 3, that is nothing but the highest point. Sorry, at highest point, this is h. Now if it should complete going to there, that means they have given you 7 gr. That means when it needs to reach to that see if it is having more, that means if it is having more than 5, it starts completing like it moves from, it comes here, and that means its value is root 5 gr. Then the complete loop is completed, but still it has some velocity in it. So what happens? How much of velocity it is having? Root one more point 5 6 7. So here it is going to be root 7 gr. That means if you conclude this into 4 halves, coordinate 1, coordinate 2, like pieces, 4 pieces, then you have to complete this 4. If you are completing this 4th one also, then only your complete loop is completed. So you have to add up still more 3. That means I am going to tell you over here the velocity is going to be root 3 root 3, just a minute, I'll change the color. So tension over here is going to be root 3gr, right? So root 5, 6, 7, it's going to be at highest point. At root 7gr, it is going to be at the highest point. So we got the velocity at the highest point. So at t min, the velocity is root 3gr. At t min, velocity is root 3gr. Then if I am getting the velocity root 3gr over there, if I try to substitute the t min formula, t minimum formula is mv square by r minus mg. mv square by r minus mg. Now let us try to substitute that. So when I substitute that, I am going to get 3mg minus mg. So that t min is nothing but equal to 2mg. When I try to find out the ratios of these both, then I am going to get these ratios like T max and T min. T max is given as 8 mg and T min is given as 2 mg. So mg gets cancelled, 2 ones are 2 4s are. So the ratio over here is 4:1. That is option number 2. Hope this is helpful for you. Let us go for the next question. So here the next question. The minimum speed of a bucket full of water drilled in a vertical circle is given as 10. Well, see, the length is given as, radius is given as 10 meters at the height at the highest point, so that the water may not fall in. So that means the water should not fall in. When you take a bucket, if you are rotating it nicely, and when you rotate it, the water, when it comes up over here like this, the water should not fall down. That means at what speed it should move. That means the minimum, if the tension should be maintained when it is at the highest point, the minimum tension over there, so the minimum velocity that body have to rotate in that case is v is equals to root gr. V is equals to root gr. In that case, now what we are going to do is, at the highest point, so that water may not fall, the minimum speed they are asking you. Minimum speed is, if you take g as 10 and r is given as 10, so g is given as 10 and r is also given as 10 meters, so your velocity is going to be equal to 100 root 100, that is nothing but equals to 10 meter per second. So your option is fourth option, right? So the minimum speed of the bucket should be at least 10 meter per second if it is of length 10 meters, right? Next, I hope this is also helpful. Let us go with the next question. When you are coming to this question, an inclined track ends in a circular loop of diameter d. From the height on the track, a particle should be released, so that it completes the loop in a vertical plane. So when you come for this, you people have to know, when you need to complete a complete loop in a vertical plane, your velocity should be equal to root 5gr. So velocity at lowest point is root 5gr. Okay, now what they have given is, they have asked us to relate it. Okay, they have asked us to relate it with height. Okay, when you go with freely falling body or vertically projected upwards body, your velocity at the lowest point will be equal to root 2gh. That means when you consider it in the circular position also, your velocity over here is going to be root 5gr, right? So now we will be relating this one and this one. Now we'll see, to complete the complete circle we need at least root 5gr, and if you need to throw it and reach it, reach it to the maximum height, you need root 2gh. So I am equating in terms of height, I will use this formula. In terms of loop completion, I will use this formula. So I want to relate these both because they are asking you from what height you should release the particular body. So when I try to equate these both, then I am going to get it like around something root 5gr is equals to root 2gh, right? So now from here I am going to solve this. So I need at what height it is going to be released from. So I am going to find the height value over here. Now let us take down this root and this root, and it will be left over with 5gr is equals to 2gh. Now if I try to cancel, I can cancel g and g. So the g and g also goes away. 2gh is 2g, g is cancelled, 2h is left. So from here h value is, h is equals to 5 by 5r by 2. So r is nothing but radius, r is radius. Okay, I am writing it smaller, so r is radius. Now in terms of radius, if I want to go with the diameter is nothing but 2r, whereas I can write that r is equals to d by 2. So I'll write that r as d by 2. R I'm going to write it as, okay, let it be. In the next step I'm going to write, so h is equals to 5 by 2 into d by 2. Okay, so now I am going to be left over with 5d by 2. So my height in terms of, 2 into 2 is 4. So my height in terms of diameters, because the answer is given in diameter, so I have got the value in diameter for y'all. So the option over here for the height is 5d by 4, option number 3. Right? Hope this is helpful for you. Let us meet in the next assignment. Until then, bye.